In this video we're going to look at connecting up a solenoid points motor. We're going to use a capacitor discharge unit to power it, and we're going to, in this case, use a laptop power supply, an old 19.5 volt laptop power supply, which will provide power to the CDU. The CDU will store the charge, and then using a switch we're going to select either one or the other of the coils on the solenoid to throw the points. Okay, to start off with, we're going to repair the power supply. This is an old Dell laptop power supply, and if we have a look at the specification on the back here, it's got 19.5 volt DC output up to 6.7 amps, which is completely sufficient. We only need a couple of amps. So first thing, cut the old connector off. Then we need to strip back some of the outer insulation. So make some little nicks into the cable, fold it over a few times, and then strip the outer off. And we've got two thicker cables, which are the 19.5 volt supply, and then we've got a sense cable and a piece of string in there that just holds the cable together. So we strip that off, strip the two wires. These are good thick wires. I guess they have to be for 6.5 amps. And that's our power supply done. Next we get the CDU. 4 terminals on the CDU, 2 of them are the inputs and 2 are the outputs. Now, if you're feeding the CDU with AC, you can feed it with up to 16 volts AC, or DC up to 25 volts. So we've got 19.5 volts DC, and we have to get those 2 cables the right way around. Now I'm going to take a guess that black is negative and white is positive here, and looking at the terminals, we've got the AC negative or AC positive there, so I'm going to connect that up. Now, these cables are quite fat. We don't want any strands getting into the neighbouring terminal, so we probably should have a little bit less cable exposed, a little bit less of the conductor exposed. What I don't want is any free strands touching the neighbouring terminal, because with this power supply able to provide 6.5 amps, that would result in quite a large spark. So have a close look at those. They look okay. So we're going to plug the power in. And it's a bit tangled up here, but we'll get there. Okay. So here we are, plug the power in. And on this particular CDU there's a ready light that lights up to tell you that the capacitors are fully charged. And I don't know if you can see that on the video, we've got a red LED lit there. So we'll just turn the current off. So I've unplugged the power supply. That LED will continue to be lit for some time because the capacitors will continue to store the charge. Next we're going to get our switch and our solenoid points motor and connect those up. Now the points motor's got 3 cables and 2 solenoid coils. There's a common black cable that's connected to the centre of the 2 coils, and there's a red wire and a green wire on this particular solenoid points motor that's connected to the other end of each of the 2 coils. So if we supply a voltage between the black and the red, this coil will be energised and the solenoid will move this way. If we supply it between the black wire and the green wire, the solenoid points motor will move in the opposite direction. So we just need to strip those cables there. Sorry, just do that on camera. Doing this carefully so we don't pull them off the solenoid, because that would be not good. So I twist the cables like that, and then we're going to connect these into a terminal block so that we can extend them back to the CDU, because you only need one CDU in general for a layout. So we'll put the black wire in the centre, I'll screw that up, green wire in the side there to that terminal, and red wire to the remaining terminal, like that. Okay, so your solenoid points motor could be some distance away from your CDU and your control panel with your switch in. So to connect that back to the switch, you want some fairly hefty wire, and normally I'd recommend 16/0.2, which is a stranded cable, and it's got 16 cores. In fact, I can show you on this brown here. There are 16 cores in there, each of 0.2 millimeters in diameter. And if you've got a larger layout, you might want to use 24/0.2, which is 24 cores of 0.2 millimeters diameter. Now for this setup that we're just doing on the desk here, I'm just going to use some much thinner cables just to make my wiring easier, and I'll pick the same colours. There's a green, black, make sure that's in there, the terminal properly, and a red. Now we're going to connect the black back to the CDU negative terminal, which is this one here. Then we've got the green and red wires. I'm going to connect those to the switch. They're not perfect for these screw terminals, but they will work, I think. And then the red wire to the remaining output terminal from the switch. Like that. Okay, then we want a common wire coming from the CDU positive. I've chosen a yellow wire just because it's easy to hand, and I'm going to put that into the common switch contact. And that's our first set of points wired, so we just go through that. Negative and positive into the CDU. CDU will store up a charge, and then when we want to operate the points, we'll operate the switch, which will direct the positive feed either to the red or the green wire, and that will go to the solenoid points motor. Let's move these across a bit. And then the negative from the CDU goes direct to the common wire of the solenoid. So let's just power up the power supply. CDU LED is on, and hopefully when we operate the switch we get the solenoid operating, and that's a very positive action. Also, if we have a look at the CDU, each time we operate the switch the LED goes out briefly whilst the capacitors are discharged and feed the coil, and in fact if you operate the switch in the same direction, although you're feeding the coil and the points aren't actually moving, you can see it's discharging the capacitors. There's about a half a second before the CDU recharges, so you can operate the points almost as fast as you like. Okay, so the next step is to connect up a points position indicator. So here's the points position indicator, exactly the right way up. This one will monitor up to 8 sets of points, so it's got 16 input terminals along the bottom here, the common connection, we'll come back to that in a minute. There's a power supply input which needs to be between 12 and 25 volts DC or 12 and 16 volts AC, and then there are output terminals to drive LEDs. Now, for each set of points you have 2 LEDs, and I've got some pre-wired LEDs here just to make my job a bit easier. I've got a red and green there, but I'm going to actually use red and blue because that makes it a little bit more straightforward for anybody who's slightly colourblind to understand this video. So there are the output LEDs. So what I'm first going to do is to connect the points onto the points position indicator inputs. Okay, so I'm going to try and use the same colours as we've got connected to the points position indicator. Now, unlike the points position indicator, these wires can be much thinner because they're not actually carrying a great deal of current. So we've got the 2 connections to the input of the points position indicator. Now I'm going to make the connection here, but actually, because the points position indicator will probably be by the switches, you'll probably make the connection a bit further across there at the switch itself. Oops, I just let the red fall out there. That's the 2 reds in there. The 2 greens in there. Now we also need to make a common connection. That's to here on the points position indicator on the very right hand side. Now that would normally connect back to the CDU here because that's also at the control panel, but in fact I'm going to connect it into this terminal in the middle here. Now, even without a power supply to the points position indicator, we can test its function. So if I operate this switch and you look at the yellow LED here, each time I operate the points, that LED lights briefly. Now that tells you that the wiring is correct on the input side. Now, even if I operate the switch in the same direction continuously, you can see the yellow LED is lighting. Okay, now it's time to connect up the power supply to the points position indicator. So I'm going to use the same white and black wires, and I'm going to connect into the CDU input side this time. Now, hopefully I can get these wires in. A bit of a squash in here actually now. You'd be better off having another terminal block to do this. Can't quite get that one in. There we go, that's in. Okay, so we're going to have a 19.5 volt DC supply on here, and I'm going to connect that into the power input of the PPI. And we'll turn the power supply on just to check everything's functioning. Check those are wired okay, yep. Okay, so there's our setup. Put the power on. Okay, so we've got the LED lit on the CDU because that's fully charged. We've got the red LED lit on the PPI, and each time we operate the switch to change the points, we get the yellow LED lighting there. So the next thing to do is to connect our output LEDs, the red and the blue as we said, and I'm going to turn off the power whilst we do this. If I operate the switch to operate the points, that will discharge the CDU. Okay, so it's important to get the wiring the correct way around for this. We've got terminals marked A, which stands for anode. That's the positive output for the LEDs. And we've got terminals marked C, C1 and C2 here. Those are for the cathodes. So I'll take my LEDs. I'm going to strip some of the cabling back because we haven't got enough conductor exposed at the moment. Then I'm going to twist the two positive wires together like that. And fold them over. And they're going into the A1 terminal. And the negative wires. Now I'm not quite sure which way around we're going to have these, but we can swap the connections over if we get the wrong order. So the black wires go into the C1 and C2 terminals. Let's check they're okay. Yep. And those are all the components of our system. So we just power that up again. Okay, so you initially saw a flicker there when the unit powered up, and we've got the blue LED currently lit. In fact, if I hold those up there, blue lit, which is connected to the C2 terminal. So I've got the two LEDs now connected on the output of the PPI, red and the blue. If I operate the switch to the left, the blue LED lights. If I operate it to the right, the red LED lights. And you can hear the points switching at the same time. That's all there is to it. So I've got the two LEDs now connected on the output of the PPI, red and the blue. If I operate the switch to the left, the blue LED lights. If I operate it to the right, the red LED lights. And you can hear the points switching at the same time. That's all there is to it.